Right. Last day we were just discussing about the concept of constructor, and we just learned how the default constructor is working, and once it is overloaded, how it is working. Overloading is basically using the same method name but using different signatures, right? So what is that different signatures? Same method name. So constructor is special method. No, constructor is a special method having same name as a class name. Right? These things may be a little bit difficult to remember at the initial stage, but gradually you will remember these things when you practice. Right? Okay, constructor is a special method having the same name as class name. For an example, if there is a class student, let me take a new class. If it is class student, the constructor is basically is same. You can say student is the construct, that is default constructor. Right? That is default construct. It is right. So this is default constructor, and in overloading, what you're going to do, maybe you can assign student, like string, let's say some other values. So that will create a different signature. This is what the overloading is. Okay, let's use the main method. And I can create objects using the default constructor or overloaded constructor. Okay, let's put some two statements only. I'm going to put system.out.println here, default. And system.out.println overloaded. Then let me create two objects. One object number one, student, st1 is equal to new student, that is using the default constructor, and student say st2 equal new student, and this is using overloaded constructor. I'm going to give first name, let me save. student. You can see the first one is default. First one is printing default. When you create the object, constructor is called, right? Same time when you create the object, constructor is called and it is printing default. And the second one is overloaded, it's printing this one. It's getting these two names, and actually you can do something like meaningful thing. You can say string first name and last name are attributes of this class, and at the same time you can assign this dot first name equal this first name that you are giving, and this dot last name is equal the last name that you are giving. Likewise, you can assign that values and then you can recall them later. But here you are not doing anything, but if you want, you can recall them. Maybe print details. Let's print details. Let's use another method, public void print details. This is to print the first name and the last name of the student. So let's print both together. FN and the last name. First name and the last name. You can see still nothing happens because I have not called. And I'm trying to print details of the first one. st1 dot print details. Same time trying to print the second one, st2 dot print details. Save and let's see. Okay, default, you can see it's null. Null means nothing. Nothing is there because default constructor is doing nothing. It's not assigned the FN and LA. But the thing is like the overloaded constructor, this one is assigned the Minaga Menuka, this one to the variables. So this is to show you the constructor overloading. This is default, this is overloaded, right? So let's comment and then tell them default and this is overloaded. Okay, you can just try this now. Please try it now. Okay, the next concept that I'm going to add today. So now actually we are learning about this WOP, object-oriented concepts. So next I would like to add the concept of encapsulation. Right, encapsulation. Encapsulation is actually, you know, the capsules we use that mainly in when you are using drugs. Inside the capsule the particular chemical is there, but we are not going to explore that. Actually it is not exposed to us. Example, think about a capsule like okay, this is what a capsule is. So inside a capsule, right, inside a capsule, there can be any kind of, here inside the capsule, there can be any kind of ingredient that we are not going to see. So what is the idea? Why we are using encapsulation in programming? Why we put into the capsules or why we cover things in the programming? There is a reason. Okay, the attributes and all that we use in programming, if somebody is directly accessing that attributes from another class and editing that, that is a problem. We don't know. We should have a control access method to modify these attributes. Example, let's think something like this. Okay, so for an example, think about our heart rate. Heart rate inside our body. So there are drugs which can increase the heart rate, decrease the heart rate. But the thing is, we cannot go and tell our heart, hey heart, now your heart rate should be this one. You cannot edit the variable directly. You cannot edit it directly. But still, you have methods of changing it. Okay, let's say the oxygen level or glucose level or something in the body. Again, we cannot go to the variable and edit it. We cannot tell oxygen level should be 10, 20. Likewise, we cannot tell, but there are methods of controlling it. Okay, another one, TV channels. In TV, you can use remote to change the TV channel. That is possible. Or you can use a button to change the TV channel, but you cannot go and edit it. The advantage is, so there is a limitation and practical controlling to the particular variable. Okay, for an example, let's say a TV has channels from 1 to 100. If you try to give something beyond 100, it won't accept. But if variable was editable, you can go and say channel equal 120, channel equal 200, channel equal 400. But this method will provide controlled access to the variable. So one thing is, the variable cannot be accessed externally and edited. The second thing is, it is given a controlled access. Okay, let's think about marks. Okay, I'm going to add student marks, right? INT or double student marks. This is only an example. Okay, here in the main method, I can tell, right, any student has a student mark once defined. This is applied for all the objects. So I can go and tell student marks equal, let's say minus 200, possible. Here also, let's say ST1. ST2, but student marks equal, let's say 600. Possible, because so those are valid integers. Both are valid. Both are valid integers, therefore I can apply. Nothing wrong. But these are practically invalid marks. So if it is a subject, the mark should be between 0 to 100. Right? But if you put double, it can accept any value. It can go like beyond 100. It can be lower than 0. Anything can be. This is dangerous. So you need to control that. To do that, you are making this private. You are making this private. Right? So even it is a private one, still within the class you can do this modification. But the thing is, you have to do this via a method. So that is the advisable way. What is the method? Okay, let's say private double student marks. I'm setting a public variable, a public method, public void set marks. And you are going to get MK, the marks in double. This is the standard way of doing set marks. We'll set the marks. This dot student marks equal this MK. And then another variable, public, another method, public double get marks. Setters and getters. These are called setters and getters. It's going to return these dot marks. Okay, that is the acceptable way. The variable will be defined as a private variable, but it is accessed using public access modifier. And the advantage is you can control. And you can check whether if MK is less than or equal to 100 and MK is greater than or equal to 0, then only you are going to set it. If not, if it is a minus mark or something, you are not going to do. Else, let's change it to 0. But you are setting it only if a valid mark. So that can be controlled now. Now, if now direct setting, now somebody should set the marks through the variable. through the method. And if minus 200 entered, it won't set it. If 600 entered, it won't set it. We can check how. We can print it. st1 dot get marks. Same time, st2 dot get marks. So let's see what will happen. You can see both are 0. Why? If I try to assign a negative number or a number higher than 600, it will be set to 0. But if you try to set a valid number like 98, it will be set. It will only accept a valid range. The range check is done through the method. But if you use variable, you will not be able to do that directly. But this is controlled method to access the particular variable. It only work according to our instructions. Okay, you can start doing this now. This is one example of how you can use setters and getters. This entire concept is called encapsulation. I will give a note on that also. But before that, please write down this. Okay, once you convert everything, so normally what will happen? Within the class, you can access the variable, that doesn't matter, right? But the thing is, if you try to access the variable from any other class, it won't be allowed. It's restricted. So that is what we need to do here, right? Okay, actually, so what are these other classes? That also we need to know. What are these other classes? We are always telling that within the class you can access, but other classes you cannot access. So what is this other class? Right? Other class mean it can be a subclass, it can be some other class in the same package. So there are different other classes, right? Still we can access them. Okay, for an example, think about the bank account class. Think about the bank account class. Let me save this again. Compiling Java C bank account.java. Okay, then Java bank account. You can see all the details. And I just need to create a subclass of that. Subclass means this is going to be the superclass parent class. So under that we can create children even. So that is the object-oriented principle then. So let's see what is the superclass subclass relationship. I'm going to create a new one and call that class, let's say, saving ACC. You can say extends bank account, right? Extends bank account. Now this, so I can save this as saving ACC, savings ACC. Let's save as savings ACC.java. Save. Right. So what happened when you extend? Let's implement the main method, public static void main string arts. You can say let's create object of this savings account. SA1 equal new savings account. I'm going to compile that. Java C savings account.java and interpret it. Java savings account. You can see here account type demo, how this came. Yes, account type is demo, account ID is 1000, interest rate 0, no product. You have 0 account balance. How this happened? Yes, because I have not done anything here. I have not done anything here. Yes, Minaga? Minaga?
Oh, yes.
Yeah, you're looking at me, right? Looking at my screen, right?
Oh, yeah.
Yes, I just created this and I got this result. I just wanted to know how this happened. From where this came? Account type and all these things.
Oh, it came from the class before.
Yes, parent class. You got it from the parent class. Actually, you have called the constructor in the parent class. Let's go and see the constructor in the parent class. Constructor in the parent class says here default constructor in the parent class. This one, no, this is not the default. This is the default construct. In the parent class is just implementing this. Actually speaking, this is the subclass. This subclass has called the superclass, the parent class. But if you really want to create, call this this one. If you want to call this one bank account ID, initial deposit, account string type, product, and the double interest rate, then you can just go and tell savings account. Let's call that another savings account. SA2 is equal to new savings account. Make sure you are saving both documents in the same place, otherwise it will be not discoverable. And now you can give the other things, ID. Then what else? The initial deposit. Here, this one. ID, initial deposit, savings, and all these things can be given. This one, 2. Let's erase, but it will default. It will call the default constructor of the parent class because no constructor in the child. Therefore, it's called in the parent class constructor. So let's see how these two are behaving. The first one is called in the default constructor. Oh, what has happened? Constructor say, okay, yes, error. What did I do? All these things should be able. The problem is here. I'll explain that. And I have given this, but the problem is, let's say 2. Right, okay. No arguments. Found this. The problem is we are trying to call the overloaded constructor. So then if you're calling the overloaded constructor, you have to make object of the superclass, not the children. So then it will work. But you can always call. You have to typecast that. You have to do like this. So if you want to do, right, then only it will work because the overloaded constructor is in the superclass. Here you can see, right, that is in the superclass, but default constructor will be automatically called. So No need to worry about that. So just only consider about the default constructor. No need to consider about the overloaded, right? And one more thing that I wanted to show, the encapsulation today. You can see this is balance is private. Right? I'm trying to access the balance now. I'm trying to access the balance now. I'm trying to say SA1 dot balance. I'm trying to print it. System dot out dot print and SA1 dot balance. I'm trying to print the balance. So see what will happen. No, cannot, because it is having a private access. I can't access that because it's private, right? But still I can call get balance and get the balance because it is public. So I can use the method and get that. That is public. You can try this here. Now no errors because get balance, that will work. But directly accessing the variable, no, you can't. But you can access the method and then access the variable. So that is what the encapsulation is. I hope this is clear to you. Hello? Minaga, I think you are muted.
I understand why.
Okay.
Why we need the encapsulations.
Yes. So why it is there? To protect the variable. Otherwise, people can misuse, right? They can assign any value. Okay, think about a remote controller, AC, air conditioner. So what is the minimum temperature given by air conditioner? Normally?
60?
16. Yeah, 16. Maximum?
90?
90? Air conditioner? Can it give 90?
Okay.
With the heater, totally.
Yeah.
With the heater, okay. But so if you try to exceed that value, can the remote give that value? No. Only the manufacturer instructed values, right? That you cannot reduce more than that and you cannot increase more than the given. So that is in anyway between the given range. How it is controlled? Using this public access modifiers. But variable remain private. That is the idea. Okay.
Okay. Yeah.
Because then you cannot do anything there. Otherwise, users will try to use air conditioner as a freezer and reduce the temperature to 0, right? So that cannot be done. That cannot be done because the manufacturer made such a way where you can do certain things up to certain levels only. You won't be able to reduce more than that. That is controlled using this method. Okay, just give a try. So this is, I think you have already tried this get balance and all. You give a try after encapsulating. Give a try to access variables directly you want, but you can access them through the methods, right? That is the nature. Okay. With that, I will conclude for today. Do you have any doubts before we conclude?
I think I'm fine. I think I understand it.
Okay, good. Next, let's discuss about the overriding, as well as we need to discuss about polymorphism. So more about the subclass, superclass relationships, packaging. We have to discuss more concepts next day.
Okay.
I'll stop here. Have a nice day. Bye.